This is video 3 that goes along with Unit 2, Part 1 PowerPoint lecture notes. In this video, we're going to take a look at a chemical process, and we are going to identify a chemical change as a chemical reaction. So a chemical change, we use a symbolic shorthand called a chemical or a chemical reaction or a chemical equation. It's just like a recipe for, let's say, baking a cake, right? Chemical reactions are examples of a chemical change. And it's a process in which the identity and the composition of one or more substances are changed. We start with something called the reactants. These are the elements or the compounds that undergo the change in the chemical reaction. The products now are the substances that are formed when the chemical reaction occurs. So let's take a look at this chemical process. The chemical change. An example is taking water and running an electric current through it to form hydrogen and oxygen. Notice that water is written on the left-hand side. This is the reactant. The electric current above the arrow shows us what has happened in this chemical process, and we're left with hydrogen and oxygen as the products on the right side. So the reactants are written on the left side of the arrow. The products are written on the right side of the arrow. The arrow itself indicates that there is a reaction that has occurred. Now, what we'll see when we get to unit, 6, when we look at dissolving, we also see an arrow, and that's why I said it's when a process occurs. So it can indicate a chemical reaction or some type of process has occurred. This is a chemical equation. However, it is not a balanced equation because we don't see all the same numbers of atoms on both sides. Let's take a look at another chemical change. So let's say we have nickel and hydrochloric acid. When we mix them together, we end up with this. Notice, remember we talked about having a color change. Nickel is a silver metal, and we put hydrochloric acid in a test tube. Notice that the hydrochloric acid is colorless, but when we mix the two together, here's the nickel on the bottom, we start getting this green color. And if we let this go long enough, we end up with a new solid that is a green solid, right? The products are nickel 2 chloride and hydrogen gas. You can kind of see little bubbles in this mixture that are the hydrogen gas. Can you think of some common chemical reactions in your world? Have you ever made a volcano or a science fair project? That was a chemical reaction. Do you remember what the compounds were? You used sodium, what did you use? Vinegar and baking soda. So let's take a look at this chemical reaction that we just reviewed on the last slide. Nickel plus hydrochloric acid yields nickel 2 chloride and hydrogen. Notice that we can write it out in words with the names of the compounds and elements that are involved. However, when we're doing a shorthand, we have the symbol of the element, the compound formula, hydrochloric acid, and now we see that we have nickel 2 chloride and hydrogen gas. These symbols underneath represent the physical state. We've got a solid. This AQ represents that this is an aqueous solution, meaning that the hydrochloric acid is dissolved in water. And again, the nickel 2 chloride is also dissolved in water. And we have hydrogen gas. Okay. On this slide, we go back here. How did we get this nickel 2 chloride in this powder form? Do you guys remember what we said we had to do to separate a salt from water? We've got to evaporate it. Correct. So coefficients are the numbers that go in front of to the left of, I would say, a formula or an element showing the number of units of each substance in the reaction. We can either have them on the reactants or the product side. Let's take a look at another chemical reaction, and let's break down each part of this reaction part by part. So here we have 2HGOS arrow yields 2Hg liquid plus 2 plus O2 gas. So this is mercury oxide yields, which is a solid that yields 2 units of mercury liquid and oxygen gas. This can represent the number of molecules or something that we call a mole. So products and reactants are specified using their chemical symbols. Again, reactants are on the left side and products are written on the right side. We have coefficients that tell us the number of units of substance in each reaction. And we have sometimes the little delta above a chemical reaction arrow means that energy is required, and that's where it goes. Remember on a few slides ago, we were looking at water breaking down into hydrogen and oxygen. What did we need? We needed an electric current, right? That was over the arrow as well. So notice that the number of atoms is the same on each side. So if I multiply this 2 in, I've got 2 mercury atoms, right? And I multiply this 2 into the oxygen, I've got 2 oxygen atoms. And so here we have a balanced chemical equation. Our physical states now are shown in parentheses. These are important to help us identify the kinds of chemical reaction that is occurring. So once again, the symbols that we have in a chemical reaction, we've got the plus sign that indicates we have 2 or more formulas. The arrow shows that means that it reacts. That's what's reacting, right? The physical state, S represents solid, L is a liquid, G is a gas, and AQ is aqueous. I want you to take a look at this slide and which one of these correctly represents a chemical reaction. Remember, a chemical reaction is going to be something in which we start with reactant and then we end up with something new. Also, we have the same number of atoms that are found on each side of our reaction. We also, to have a complete chemical reaction, we must also have the chemical states of each part of the reaction, right? So all of the reactants and the products have to have their physical state. Water plus heat gives water vapor is that a chemical or physical process? It's a physical process because it's water. Water plus heat gives us water vapor. It's not a chemical process. What about water liquid plus heat giving water gas? Well, guess what? That's the exact same thing as A, just written in symbols. How about C? 2 water molecules liquid with an electric current gives us 2 hydrogen and 1 oxygen. Is that correct? 2 times this 2 next to the hydrogen gives us 4. Well, 2 times 2 next to the hydrogen gives us 4, okay? And 2 times this 1 oxygen gives us 2. Do we have the arrow? Do we have the information, the electric current? And we have the physical states. I think that's a chemical reaction. What about D? D is very similar, but what's missing? We're missing the physical states, right? And what's wrong with E? E, we don't have the same number of atoms on each side of the arrow. We've got 2 hydrogen here, 2 hydrogen here, only 1 oxygen and 2 oxygen. So what's our answer? The answer is C.